term SER cable is not included in the National Electrical Code (NEC) because it is an industry term for a type of cable that is not specifically defined by the NEC. The NEC only defines cables that are specifically designed for use in electrical installations, and SER cable is not one of them. SER cable is a type of non-metallic sheath cable that is typically used for outdoor applications. It is typically made up of two or more insulated conductors that are surrounded by a non-metallic sheath. The sheath is typically made of a polyethylene or polyvinyl chloride (PVC) material. SER cable is not included in the NEC because it is not a type of cable that is specifically designed for use in electrical installations. It is typically used for outdoor applications such as connecting a light fixture to a power source. The NEC only defines cables that are specifically designed for use in electrical installations such as THHN, THWN, and XHHW. To understand why a particular cable type is or is not included in the NEC, it is helpful to understand the NEC overall purpose and structure. The NEC is a comprehensive set of standards and guidelines for safe electrical installations. It is not a design manual, but rather a set of minimum requirements intended to protect people and property from electrical hazards. The NEC is updated every 3 years by the National Fire Protection Association (NFPA) through a consensus-based process involving a wide range of stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and insurance representatives. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed specifications for various types of electrical equipment and materials, including cables, conduits, boxes, and devices. The NEC classifies cables based on their construction, insulation type, and intended use. Each cable type is assigned a specific designation such as THHN, THWN, XHHW, or OFF, and the NEC specifies the allowable applications, ampacities, and installation requirements for each type. The NEC also includes provisions for listing and labeling of electrical equipment and materials by independent testing laboratories such as Underwriters Laboratories, ALL. Listing and labeling provide assurance that the equipment or material has been tested and found to comply with applicable safety standards. In the case of SER cable, the fact that it is not specifically defined in the NEC does not necessarily mean that it is prohibited from use in electrical installations. However, it does mean that the NEC does not provide specific guidance on its installation or use. In such cases, it is the responsibility of the electrical designer or installer to ensure that the cable is suitable for the intended application and that it is installed in accordance with all applicable requirements of the NEC. This may involve consulting with the cable manufacturer, reviewing product listings and specifications, and obtaining approval from the local electrical inspector. Several factors might influence whether a specific cable type is included in the NEC. Firstly, widespread use and acceptance are important. If a cable type is commonly used in electrical installations and has a proven track record of safety and reliability, it is more likely to be included in the NEC. Secondly, standardization is important. The NEC prefers to define cable types that are manufactured to standardized specifications and that are readily available from multiple manufacturers. Thirdly, safety concerns are paramount. If a cable type poses a significant risk of electrical shock, fire, or other hazards, it is less likely to be included in the NEC. Fourthly, industry consensus is important. The NEC is developed through a consensus-based process, so the inclusion of a particular cable type requires the support of a majority of stakeholders. Considering the specific characteristics of SER cable, its exclusion from the NEC may be due to several factors. Firstly, SER cable is primarily used for outdoor applications such as connecting light fixtures or other equipment to a power source. The NEC may consider these applications to be less critical than those involving general wiring within buildings, and therefore may not feel the need to provide specific guidance on SER cable. Secondly, SER cable is a non-metallic sheathed cable, which means that it does not have a metal conduit or armor to protect the conductors from physical damage. The NEC may be concerned about the potential for damage to SER cable in outdoor applications, and therefore may prefer to specify other cable types that offer greater protection. Thirdly, SER cable is often used in residential applications, which are subject to less stringent requirements than commercial or industrial applications. The NEC may assume that electrical contractors working in residential settings are familiar with SER cable and do not need specific guidance on its installation. In summary, the absence of SER cable from the NEC is likely due to a combination of factors, including its limited scope of application, its non-metallic construction, and its prevalence in residential settings. While the NEC does not specifically define SER cable, it is still possible to use it in electrical installations, provided that it is suitable for the intended application and that it is installed in accordance with all applicable requirements of the NEC. When using any cable type not explicitly covered in the NEC, it is essential to exercise caution and diligence. Firstly, verify local requirements. Local jurisdictions may have specific rules or interpretations regarding the use of cable types not explicitly mentioned in the NEC. Always consult with the local electrical inspector or building department to ensure compliance with all applicable regulations. Secondly, obtain manufacturer specifications. Obtain detailed specifications and installation instructions from the cable manufacturer. These documents will provide valuable information about the cable's intended use, ampacity, temperature rating, and other critical parameters. Thirdly, ensure proper support and protection. Provide adequate support and protection for the cable to prevent physical damage. This may involve using cable ties, straps, or other approved methods to secure the cable to structural members. In areas where the cable is exposed to physical damage, consider using conduit or other protective measures. Fourthly, maintain proper clearances. Maintain proper clearances between the cable and other objects such as pipes, ducts, and equipment. The NEC specifies minimum clearances for various types of cables and equipment, and these clearances must be observed to prevent overheating and other hazards. Fifthly, use appropriate connectors and terminations. Use only connectors and terminations that are specifically listed and labeled for use with the cable type. Improper connectors and terminations can lead to loose connections, overheating, and electrical faults. Sixthly, follow grounding requirements. Ensure that the cable is properly grounded in accordance with the NEC. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock and equipment damage. Seventhly, inspect and test. After the installation is complete, thoroughly inspect the cable and connections to ensure that they are properly installed and secure. Test the circuit to verify that it is functioning correctly and that there are no electrical faults. Understanding the different types of cables recognized by the NEC can also help in selecting the appropriate cable for an installation, even if SER cable isn't specifically mentioned. Firstly, THHN/THWN. These are general-purpose building wires commonly used for branch circuits and feeders. THHN has a thermoplastic high heat-resistant nylon jacket, while THWN is thermoplastic heat and water-resistant nylon jacketed. Both are suitable for dry and damp locations. Secondly, XHHW. This is a cross-linked polyethylene high heat and water-resistant wire, suitable for wet and dry locations. It has a higher temperature rating than THHN/THWN. Thirdly, OFF. This is an underground feeder cable, designed for direct burial in the earth. It is moisture-resistant and sunlight-resistant. Fourthly, NMB. This is a non-metallic sheathed cable, commonly used for residential wiring. It is suitable for dry locations only. Fifthly, NC. This is a metal-clad cable, consisting of insulated conductors enclosed in a metallic sheath. It is suitable for dry and damp locations and provides excellent protection against physical damage. When working with electrical systems, always prioritize safety. Firstly, to energize the circuit. Always to energize the circuit before working on any electrical components. Use a voltage tester to verify that the circuit is de-energized. Secondly, use appropriate personal protective equipment, PPE. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Thirdly, follow lockout/tagout procedures. Follow lockout/tagout procedures to prevent the circuit from being accidentally energized while you are working on it. Fourthly, work with a qualified electrician. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. It's also good to note a few things about cable ampacity. Cable ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables that specify the allowable ampacities for various types of conductors based on their size, insulation type, and installation conditions. Ampacity is a critical factor in electrical circuit design, as it determines the size of the conductors needed to safely carry the intended load. Overloading a conductor can cause it to overheat, which can lead to insulation damage, premature aging, and even fire. The NEC provides ampacity tables in Article 310.15 and Annex B that list the allowable ampacities for various types of conductors based on their size, insulation type, and installation conditions. These tables take into account factors such as ambient temperature, number of conductors in a raceway or cable, and the presence of thermal insulation. The ampacity of a conductor is affected by several factors, including temperature rating, ambient temperature, number of conductors in a raceway or cable, and conductor material. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings. Higher ambient temperatures reduce the ampacity of a conductor. When multiple conductors are installed in a raceway or cable, their ampacities must be derated to account for the increased heat generated by the conductors. Copper conductors have a higher ampacity than aluminum conductors of the same size. When determining the ampacity of a conductor, it is important to consider the terminations and equipment to which the conductor will be connected. Terminations and equipment are often rated for a specific temperature, and the conductor ampacity must be selected so that the temperature rating of the terminations and equipment is not exceeded. The NEC requires that conductors be protected against overcurrent by fuses or circuit breakers. The overcurrent protection device must be sized to protect the conductor from overload, but it must not be so large that it allows the conductor to be damaged by a short circuit or ground fault. When selecting an overcurrent protection device, it is important to consider the ampacity of the conductor, the interrupting rating of the device, and the characteristics of the load being served. For example, Table 310.15b16 in the NEC provides ampacity values for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air, based on conductor size and insulation type. These values are based on specific conditions, and adjustments may be necessary depending on the actual installation conditions. Article 310.15c of the NEC provides adjustment factors for ambient temperature. If the ambient temperature exceeds 30 degrees Celsius, 86 degrees Fahrenheit, the ampacity of the conductor must be derated. Article 310.15b3 of the NEC provides adjustment factors for the number of current-carrying conductors in a raceway or cable. If there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be derated. The NEC provides examples of ampacity calculations in Annex B. These examples illustrate how to apply the ampacity tables and adjustment factors to determine the allowable ampacity of a conductor in various installation conditions. Always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements.